Welcome to Cryp version 2.0. This is Aaron Bittman, software developer. Before I get to the program itself, I should explain the version history in case any of my other Cryp demos cause confusion. I wrote Cryp Swing version 1 to demonstrate my Java skills and to learn about Swing classes in 2019. In 2020, I wrote another version of Cryp in Python, this time adding more features, making it more powerful. But then I switched back to Java and added those features to the Swing version, plus even more features in 2021, thus creating Cryp Swing version 2.0, which was my latest and greatest until now. I just added those features to my Python version of Cryp as well, resulting in Cryp 2.0, which I will now demonstrate. So with that explanation out of the way, let's get to the point. What is Cryp? Back in the 20th century, I enjoyed solving cryptograms in magazines like this one. Cryptograms are messages written in code. Specifically, they're encoded with a monoalphabetic substitution cipher. In other words, one letter in the English alphabet would be substituted with another letter or symbol. The message in code is called ciphertext. The plain English to which you translate the encoded message is called plaintext. So for instance, if a plaintext A is written as a ciphertext C, then a plaintext A will always be written as a C throughout the message. Of course, solving such problems with only a pencil can sometimes be difficult and tedious. When you guess that a ciphertext symbol represents a certain plaintext letter, you have to search the whole puzzle for all occurrences of that symbol to translate it to the plaintext letter. If you later change your mind, deciding that's not the plaintext letter you want to guess, you have to search the whole puzzle again to erase every occurrence of that plaintext letter you wrote. Obviously, that kind of task screams for a computer program to do the work for you. Furthermore, a computer can quickly search through a dictionary file and suggest to what plaintext words a ciphertext word might translate, based on whatever criteria you decide. So when I learn a new programming language and come up with projects for myself to get practice writing in that language, I often choose to write a program to help me solve cryptograms. I typically name this program Cryp, short for cryptogram. Maybe someday I'll write some other version and change the spelling to CRIP so I can claim it stands for Cipher Resolution Interface Program or something clever like that. Look at my code and you'll find that I drew some of the code from this book, Cracking Codes with Python from No Start Press. I revised that code heavily so that it works better, at least in the puzzles I tested. Of course, if you search the internet, you can find many cryptogram crackers that work better still. However, I feel that even many of the better programs leave much to be desired. Many of them are only text-based. They might try every possible solution for one word, and based on each of those solutions, try every possible solution for another word, and so on. That approach can often be a good beginning. But what if one of the words in the solution isn't in that program's dictionary file? What if another word that fits that pattern is in the dictionary, so the program takes a wrong turn? What if there are many possible solutions in which the words fit but don't make sense when put together? I feel the need for a human user to intuit what direction to take and to guide the program accordingly. And to help that human user do the job quickly and easily, I feel the need for a graphical user interface. So, let's run it. First of all, I'll mention that even if you don't want to bother typing up a whole puzzle on your computer, this program can still help you by searching individual words. You can simply hit the Solve Word button, and you'll get an interface to examine one ciphertext word. I can enter one here and now, and find all the words in the dictionary that fit that pattern by hitting the Solve button. I can search through these 65 results and try to guess which one is most likely, but there are ways of narrowing it down. For instance, I can check the like exclusion option. Like exclusion is my own personal term, meaning that a letter cannot translate to itself. For instance, a ciphertext A cannot translate to a plaintext A. Several people have pointed out to me that there's no rule that like exclusion must apply to a cryptogram. However, I've never seen a professionally published cryptogram that didn't have like exclusion, so I see no reason not to check it, especially when it can narrow down the possible answers. So now when I hit solve, the program has narrowed the results down to 38 possible words. Another thing I can do to narrow down the possibilities is to tell the program that I know, or assume, that one certain ciphertext symbol translates to a certain plaintext letter. For instance, suppose I've been working on the puzzle and decided that a ciphertext Y is an E in plaintext. I enter an E over the Y and hit solve. As you can see, that guess really narrowed it down. And because I'm a human being, I know what most computer programs don't, that the most likely word here is problematic. So that might be my next guess as I work on the puzzle. I should also mention, for those of you without experience in solving cryptograms, that when choosing a word to solve early, it obviously helps if that word is long, but something even more important is to find a word with many repeating letters. I'll demonstrate. I'll hit clear to clear all the ciphertext and plaintext I entered, and enter even a short word with repeating letters. As you can see, even without like exclusion, I get a short list. So this single word solver window alone provides the heart of my program. But of course, Cryp can do more than that. And by the way, in case you were wondering about that Use Puzzle option, I'll get to that eventually. Right now it's useless because I haven't entered a puzzle yet. But for now, let's go for a whole puzzle. Here's a file in which I typed up a few puzzles from an old cryptogram magazine. Now, in my puzzle solver window, I'll hit populate and paste in the ciphertext. You'll notice that here too we have a like exclusion option, although I found that when Cryp makes its initial guesses, like exclusion makes little practical difference. So I'll just hit OK. As you can see, Crypswing has solved almost the whole puzzle, leaving us just a little bit of work to do. It's obvious that N translates to Y, so I'll click on the plaintext space above any N. Now, when I hit the Y key, Cryp will translate every N throughout the puzzle to a Y. Likewise, if I click above any S and enter a K, all the other S's will get a K. So in more difficult puzzles, I can instantly see what consequences my guesses would have. Well, in this case, they're not even guesses, they're obvious choices. So for a real demonstration, let's try a harder puzzle. When trying to solve this puzzle, Cryp made some good choices and some bad ones, and it's clear to a human user which choices to keep and which ones to change. By the way, you'll notice the bottom of the window gives the frequency of each ciphertext letter, both alphabetically and in descending order of frequency. This can help us make some guesses in some puzzles. Now, what's this word? I'm not sure, so I click on any plain text space above the word and hit Solve Word. As you can see, the window pre-populated with the ciphertext and known plaintext, although I'm still free to edit those. But for now, let's search for it as is. Now, if I click on a word, I can either click on the Select Word button or just double-click the word. And the puzzle window will populate the plain text accordingly, not only above the word itself, but also for the corresponding spaces throughout the puzzle. To demonstrate the power of this program, let's try a hard one. Here's one from the part of the magazine labeled Expert Section. By the way, I should mention that this version of Cryp is often good at initial guesses, making even a lot of hard puzzles easy. I've only found a few that remained hard, like this one. Clearly, this puzzle has too few clues for Cryp to come up with an initial guess. By the way, this is a minor bug in my program. Sometimes a little extraneous text appears in the plain text. It's no big deal. You can just delete it or ignore it. Anyway, we need to make an initial guess, so let's try the author's last name. Nothing. Well, apostrophed words are often a good starting point. Ain't. Oh wait, now the first word is A-I-N. Forget that. How about can and can't? Well, a sentence that begins with can is typically a question, and I see no question mark here. Don't? Well, people don't don anything anymore. Let's? It looks a bit unlikely, but let's try it. Oh yeah, in Cryp you can open multiple word windows and compare the results side by side. Now, even with like exclusion, I get 36 solutions. However, we're assuming some letters for now. For instance, we're assuming that a ciphertext K translates to an L. Based on that assumption, there will be no L in our word now. What if we could tell Cryp to exclude all solved letters in the puzzle? Well, we can, by checking Use Puzzle. That narrows it down. Let ideas let's. Let views let's. These don't seem to make sense. Let's go back to the first word. Ones. One finds ones. Let's try it. I'm not familiar with the author of this quote. Fortunately, there's Google. You get the idea. Feel free to play with the features. And here's a bonus. In addition to Cryp, I wrote a program to do the reverse. I named it by spelling Cryp backwards and calling it Pyrc. You just get a quote like this one, run the program, and Pyrc will generate a cryptogram for you. You can easily create test cases this way. And there it is. So feel free to peruse my code and feel welcome to give me any feedback on GitHub.